Okay, so here we look at evaluating function at different input values. And so first example is the function f. Function's name is lowercase f of x equals 5x minus 1. Okay, so now once again, as a quick review, this function notation here means, so the lowercase f right here in front, it means it's a function's name, and here it coming along with attached with some sort of formula and involves the variable x. So now the x here is indicating that it's telling me that the x in the formula would be the input for the function. And so with this function now, so when I'm looking at f of 1, meaning I want to take input x equals 1 for the functions. And so now the notation f of 1 tells me that I'm gonna substitute 1 in for x in the formula, and then from there I can just go ahead and evaluate my function's value. And now, by the way, back to this function value, what the function tells you to do is that whatever the input x is, the function will multiply the input quantity with 5 and subtract 1 from it. And so here that's what we do. So here I'm taking the input to be 1, so my function's value would be 5 times 1 equals 5 minus 1 equals 4. So 4 right here would be equals to the function's evaluated, the function's value at 1 equals 4. And that's what the meaning is of the 4. So if we try again, once again, in the same example, I would like to do, this time, how about we take the input 2, for example. So f of 2. So once again, 2 is going to be the substitute for my x. So in the formula 5x minus 1, I'm going to go 5 times 2, x equals 2 this time, minus 1. And so that means the function here, the way how we evaluate is 2 times 5 is 10, minus 1, that equals 9. So 9 here is the function's value at x equals 2. Or in other words, you can write it f of 2 equals 9. That's one way you can understand it. And so now, once again, if you look back at the function, just whatever the input for x is, whatever x equals to, the function is going to multiply that input x to 5 and minus 1. So if you want to do something a little outside of the box here, if you want to do f of t, for example, so this time I'm taking my input x to be a t, a quantity t. I'm taking my input to be a quantity t. And so even though I do not know the exact value for t, but I still know that t is going to be some existing quantity. So my function is going to become 5 times t, because once again t is a substitute for the x, minus 1. And now whatever the quantity t can be, we're going to go 5 times t, which gives me 5t minus 1. And this is going to be our function's value at t, at x equals t. Or if you try f of say an a plus 1, for example, f of a plus 1, and what's going to happen here, once again, my input argument, my input of the functions. Now originally the input is simply an x, okay, but now the idea is you can take different values, x can take on different values, and then depending on the values, the function evaluate that value and end up into different values. So now x here in my function takes on the quantity a plus 1. So my function is 5 times the input, and the input in this case is a plus 1 and minus 1. And so that's how I put in my inputs for the functions. And so here it's going to become, now we can just do a little distributive law, 5 times a, 5 times 1, so I have 5a plus 5 minus 1. And so in the end it turns out to be, now 5 minus 1 is, they are like terms, so we can combine like terms here. So we have 5a plus 4. That's my value of the functions after I evaluate the function at x equals a plus 1. Same function, you can also do same function f of x. What about we can do t plus h? Okay, so once again, t plus h is a new quantity that I substitute for x. If you pay attention once again, if you look back at the function f takes the input x for whatever x values can be, equals, and what the function f does to the input here is it's going to multiply the input by 5 and subtract 1. So here in this problem, my function is still remains the same function. The only thing different now is that my input variable takes the quantity t plus h, and so as the way what the function is doing to its inputs, the whole input t plus h is going to be multiplied by 5 according to the way how the function is processing the input. And then after multiply by 5, we subtract 1. And so now we can go 5t plus 5h minus 1, because we can do the little distributive law by multiplying 5 to each term in the parentheses. And here I have just simply 5t plus 5h minus 1. And we can't really simplify any further because there are no like terms and whatsoever. And so that's how we evaluate the function f of x equals 5x minus 1 at different, taking on different x value. So if we want to get comfortable with the idea, let's try a different function. So I'm going to call that example number 2 my function this time, and we can even name the function differently. So this time I'm going to name my function capital F of x. Okay, it's just a function's name, but the function, once again, the x in the formula attached to the function is the input indicator. So what it does here is that my function, what it does to the x input, it's going to do 3x minus 4. Or how about plus 4? I changed my mind. So the function's name is f of x, is capital F, is the function's name. Anywhere you see the x in the formula of the function, it's the input argument of the function. And here what we're having here is, once again, what the function does to the input is multiplying the input by 3 and add 4. So now in the first problem, what happened if you do capital F of -1, for example? Okay, so now this time in my functions, this function here is taking on the input value. Well, basically it's the meaning here is the meaning x is taking value x equals 1. And so now when x equals -1, you do 3 times -1 plus 4, and that's -3 plus 4, and that equals 1. So the functions 1 is the function's value at x equals -1, or in other words, you can write it as a notation: f of -1 equals 1. Okay, and we can try a different value again. How about we're looking for f of 5? So this time, the 5 that's standing in the place of the x is telling me that the input argument this time is switched to a value 5. And so now the function, what the function does to the input is it's going to multiply the input 5 by 3 times, and then plus 4 after it. And so now, and once again, you can see that just simply wherever you see the x in the formula, you just simply substitute that x by the value for it, by the supplied value for it. And so now I have 15 plus 4, and that equals 19. And here's my final function's value, my evaluated function's value. And here, finalizing the problem, I have capital F of 5 equals 19. And that's how we evaluate the function's value. Now, and once again, let's try one more step further. What happens if you want to let x equal some sort of, how about a plus h, or something like that? Okay, so the idea now is the x in the function, the input quantity in the function, the input of the functions is this time taking on the quantity a plus h. So once again, on the side of your note, the x this time would be equals to the whole x plus a plus h actually. Okay, so your function's value is going to be 3 times, but instead of x you write a plus h, the whole quantity, plus 4, and equals to 3a plus 3h plus 4. And unfortunately at this point here there is no more like terms or whatsoever to combine, so here's our final answer. It's the function's value, but depending on the value of a and h again. Or in other words, you can write a plus h, f of a plus h equals 3a plus 3h plus 4. And so here, these are the examples of how you can evaluate a functions at different x value. Maybe one more quick one here for you to get comfortable again. How about this time? In my example number 3, the function here, and we can call it a different name again. How about we call it a g of x this time? Okay, so my function's name, the real function's name is lowercase g. The x in the function is the input. And so my function is 2x squared plus 1. Okay, so now this time what the function is doing to its input, what the function does to its input is that it's going to square the input first, because once again the x here is the input indicator. It tells me that in my function only the x is the input variable can be changed. So it's square the input, multiply the input by 2, and plus 1. So if you try x equals 1 for example, then as a notation we have g of 1. We plug 1, or we substitute 1 into for x, and we have 2 times 1 all squared. Now notice the square here is for the x, not for the 2, so you have to do square of 1 and then times 2 and then plus 1 according to the order of operation. So here it's going to be just r2 plus 1 equals 3. So my function's value after evaluation is 3, or in other words, g of 1 equals 3. So, and let's try again. If we let x take the value, of say -2 for example, then notationally we would write g of -2, and you can see that my -2 is replacing the x. And so here I have -2 is the input. What the function does to the input is we're gonna need to square the input and then multiply that square quantity by 2 and then plus 1. And you can see that my intention here is to write the whole problem sequentially in the order of operations, so that you can also learn back on some of your skill on the order of operations here. So now squaring the -2 is going to be a positive 4 times the 2 again and plus 1. And so now your overall answer, 2 times 4 is 8 plus 1 is 9. So your answer is a positive 9. And once again, 9 here is the function's value, the value of g after the input is taking -2 as the value. So, or I can say g of -2 equals 9. Okay, so that's how we do functions evaluations.